Let's start with lookout rule number 5. It says every vessel shall at all times maintain a proper lookout by sight and hearing, as well as by all available means appropriate in the prevailing circumstances and conditions, so as to make full appraisal of the situation and the risk of collision. So this rule in itself is very self-explanatory, but let's try to break it down into pieces, and then we will try to see what does each piece is trying to say. Okay, so let's start. Every vessel shall at all times maintain a proper lookout by sight and hearing. Okay, so till here, by sight and hearing. So every vessel shall at all times. Here, all times means regardless of your situation. If you are a power driven vessel, or if you are not under command, or if you are at anchor, does not matter. You have to maintain a proper lookout, that is at all times. No situation can relieve you from this duty of maintaining a proper lookout. This is what all times means. By sight and hearing, in sight you can use binoculars, that is also included, looking at the radar, and increasing the range so that you can see any targets. Yeah, so that is also comes under sight. And hearing is obviously sound signals, that is the hearing part. Okay, so now hearing as well as by all other available means. What does this mean? What are all other available means? So let's see. By all available means, one, we have AIS, which is automatic identification system. Secondly comes your radar and your ARPA. Third is let's say VHF. So in AIS you will get the what how is AIS helpful in lookout. So AIS will give you instantaneous identification of the target. It could be the course, speed, or any change, alteration in course and speed also. These things you can get to know from AIS. Instantaneously you can get to know. And in ARPA also you will get the same, and radar also you will get the same. As I have told you, you will use radar. Suppose you are on 12 miles, your radar is set at 12 nautical miles. So what you will do is, subsequently sometimes you will switch your radar to 24 nautical miles and scan the surrounding and see is any other vessel approaching you, or is any other vessel around you in which after some time it may develop in a risk of collision. Okay, so in that case you will use radar to see. And ARPA is automatic radar plotting aid. You will use ARPA to identify, not to identify, to basically know the CPA and TCPA. This is the main use of ARPA. Okay, so also one thing between ARPA and AIS, whenever you see there is any difference between ARPA and AIS data, especially CPA and TCPA, you will always refer to ARPA. Okay, always to ARPA, not to AIS. This is very intuitive and this is very basic. You will, whenever you will go for your segments, this is, or your ROC course, they will teach you this. ARPA is more important than AIS and more, this thing what you call, accurate, more accurate than AIS. You will know why when you will do your courses. Again, VHF, and by VHF, how are you going to use VHF? So in this case, in lookout, you will use VHF to maintain a watch, listening watch. You will maintain a listening watch, and you will monitor the movement of other vessel. So you will use VHF to monitor the movement of other vessel. In this will be helpful. Let's say if you are uh, going, approaching or departing from a port, so you will know, if you maintain a good lookout on VHF, you will know which vessel is actually coming to the port or coming out of the port. And if there is any vessel at anchor and you're going for anchoring, you will know which vessel is picking up anchor and dropping anchor. So in that case, maintaining a listening watch is very important. I prepared in the prevailing circumstances so as to make full appraisal of the situation. So basically what you're doing is you are keeping a lookout by using AIS, ARPA, VHF, sight and hearing, so as to make full appraisal of the situation and risk of collision. Basically you are using all what you can find, all these, to make a full appraisal of the situation and identify if there is any risk of collision or not. Okay, so this is more or less what lookout. Okay, so let's start with rule number 6, that is safe speed. Every vessel shall at all times proceed at a safe speed so that she can take proper and effective action to avoid collision and be stopped within a distance appropriate to the prevailing circumstances and conditions. In determining a safe speed, following factors shall be among those taken into account. So, every vessel shall at all times proceed at a safe speed so that she can take proper and effective actions to avoid collision. This line is self-explanatory. It says every vessel must proceed at a safe speed so that she can take proper and effective action. So you must at all times proceed at a certain speed as per your situation, in which situation you are. As per that, you should decide a particular speed and proceed at that speed. Why so? So that you can take proper and effective action to avoid collision and can be stopped within a distance. Okay. So, and how to determine this safe speed? This rule come into play. Okay. So let's go into this. What are they trying to say? By all vessels, state of visibility. State of visibility means either it is good visibility or it is restricted visibility. So if you are in restricted visibility, then you will lower your speed so that in case you have any situation, you have enough time, and when you have enough time, you will take proper and effective action. And also when you have time, you can also stop your vessel in a appropriate distance. Okay, so that is why they are mentioning here state of visibility. Next, the traffic density including concentration of fishing vessel and any other vessel. So here they are talking about traffic. If you have high traffic, your speed needs to be low, so that if when you are in high traffic area, your speed will be less. Again, you will have enough time to take proper and effective actions. So that's why in high density traffic, your speed should be low. Okay, so how much will be your speed will be decided by the master. Okay, then comes the maneuverability of the vessel with special reference to stopping distance and turning ability. So maneuverability of the vessel with special reference to stopping distance. Let's say if your vessel is in shallow water. If your vessel is in shallow water, then what happens in shallow water is your turning circle increases. Okay, and also your stopping distance also increases. Okay, so this you have to keep in mind. Maneuverability of the vessel. So if you are navigating in shallow water, then you have to keep in mind that if you have to make a U-turn, okay, so it will take a greater distance. And in case if you have to stop your vessel, then you should remember or keep in mind that your stopping distance will be increased. Okay. So next is at night, the presence of background light such as from shore and backscatter of your owner. This is explanatory, when you are on the bridge at the night time and you are approaching shore. So when you are at night and let's say your chart room or some your equipment's light is very bright, so what they will do is they will create a reflection of that light on the bridge screen. So what will happen due to that, whatever target or light you will see, you will not be able to see that clearly. So that is what this sentence is addressing to. Okay. So always make sure when you are at night, you need to have minimum backscatter. State of wind, sea current and proximity of navigational hazard. So state of wind again, what it will contribute to, if you have high wind, your turning circle, stopping distance, all these things will increase. Sea and current, proximity to navigational hazard is more or less like high density traffic. So if you are in somewhere where you have navigational hazard, then you will need to maintain a safe speed. Draft in relation to available depth of water. Again, draft in relation to if you are CBD, then obviously you will proceed as a safe speed because you don't have enough sea room to deviate from the course. Or if you encounter a risk of collision, then you have not a sea room, so you don't have many options to go by. Okay, so you will always proceed at a safe speed so that you can maintain a lookout and see which vessel may cause a risk of collision. Okay, so that is important. So you always proceed at a safe speed so you have ample time to decide. Okay, this is the main reason why you must proceed at a safe speed, so that you have ample time to decide what is the situation that is going to develop, and if there is any situation that is developing, what is the effective actions you can take. So when you have time, you will take effective actions. When you don't have time, then we make blunders. So always your actions should be such that you have enough time always. Coming to next, that is additionally by vessel with operational radar. Okay, so the characteristics, efficiency and limitation of radar equipment. By the term characteristics, here they are trying to address is your X band and S band. Okay, S band and X band, which is 3 centimeter and 9 centimeter wavelength. Okay, so if you are using S band and X band, both will have a different characteristics. Efficiency of radar equipment. Okay, so this I would like to explain you efficiency. Okay, let's suppose you have an X band radar and it's been working since 2 years continuously non-stop. 2 years old. Okay, and let's make which is a 1 month old X band. This 1 month old have a detection capability, let's say, of 100%. By 100%, that means it will be able to fetch all the targets. Let's say, assume it will be able to fetch all the targets at 12 nautical miles will be its efficiency. Till 12 nautical miles, it will be able to display you all the targets that are within 12 nautical miles. Okay, but this is a 12-year-old radar, so it will not has a similar efficiency as a newer X band. Okay, so this will have a efficiency somewhere around, let's say, assume 80%. If this has a 80% efficiency, that means it will be able to show you targets at around 10 nautical mile. Okay, this radar will be able to display you targets after when the target comes closer than 10 nautical miles, and this one 12 nautical miles. This is hypothetical. Okay, but the scenario remains the same. So here you have a 2 nautical mile difference. This is what here it is trying to address, the efficiency of your radar. So this is the efficiency. Okay, this means this is more efficient than this. And the limitations, you already know what are the limitations of the radar. If you have done the ROC course, you already know what are the limitations. Your range and bearing discrimination. Okay, any constraint imposed by the radar range in use. Okay, radar range scale in use, obviously. So if you are in a high traffic area, and if you keep your radar, you're in a high traffic area, and if you keep your radar at 6, not a very good idea. High traffic fishing vessel, to be more accurate. If you keep at 6, not a very good idea. And if you keep at, let's say, 3 miles, 1 mile, this is better. So when you are in a high traffic area, especially when the targets are small, and if you keep your radar on 6 miles, you will miss out on most of the targets, or your display will be cluttered, by which you will not be able to make out the scenarios, what is going on. So always keep in high traffic, keep at lower range scale. And when you are in open sea, you will keep at high range scale, 12 nautical miles. When you are at open sea, you are not going to keep at 3 nautical miles, because if you have any vessel coming at, you see any vessel coming ahead of you at 3 nautical miles, you already don't have too much time to take actions. Okay, so that is why any constraint imposed by the radar scale in use, this is what they are trying to address here. Okay, let's go to the next. The effect of radar detection of the sea state, weather, and other sources of interference. So again, sea state, if you have rough weather, your radar detection will go down. You will not have a very good radar detection because you have increased sea clutter. And if you try to decrease the sea clutter, you will miss out on nearby, what do you call it, nearby echoes. Let's say if you are here and it's rough weather, so your radar screen will look like something like this: all clutters, all clutters, all clutters. This is all sea clutters. When you will use the knob to increase the sea clutter, so what it will do is it will erase some of this. Okay, sea clutter, because you are in rough weather. So if you have any small fishing vessel here, this will also appear as a echo, and due to the rough weather, the size of the echo will be approximately the same, and you have too many echoes, so your radar will not be able to recognize. And when you will increase, this echo might also get vanished. So you should always remember this: when you are in rough weather, you cannot solely rely on radar, because once you will have too much of clutter, and when you will try to declutter, then there's a possibility that you will miss out on a target, because it will also be decluttered. Okay, this you need to keep in mind. Sea state and weather I have addressed. Then comes the interference. So basically it does is causing interference will reduce your radar performance. That's it. The possibility that small vessels, ice, and other floating objects may not be detected by radar at an adequate range. Again, the smaller the size, the difficult it is for the radar to detect, and especially if it's ice, a certain object that is not very radar